Next chapter, linear equations. Now, we talked about algebraic expressions in the previous chapter, and we said they are formed by terms. For example, 2x plus 5, 2m minus 4, and so on. The letters x and m are called variables, which means their values keep changing. When any algebraic expression is equated to a number, it becomes an equation. So 2x plus 5 equals 12 and 2m minus 4 equals 6 are now equations. With equations, we can now find the value of the variables or the unknown. When we do that, we say we have solved the equation. An equation has two sides, the left and the right. In solving equations, the key thing is to maintain the balance. That means whatever is done on the right is done on the left as well. By doing that, the equation does not change its meaning. The equation is solved when the unknown remains on one side of the equation with a coefficient of 1. So if you have 2x is equal to 4, the equation will be solved when we have x alone on the left side. To get that, we divide it by 2. And to maintain the balance, we also divide the right side by 2. And so x is equal to 2. Our equation is solved. So whereas we simplify expressions, we solve equations. For example, 2x plus 5 equals 12. We want x alone on the left side. So first we get rid of 5. To get rid of 5, we subtract it. So we have 2x plus 5, we subtract 5. And again on the right side, we also subtract 5. So on the left side, we remain with 2x, and then the equal sign. On the right side, we have 7. So we have 2x is equal to 7. To get x, we divide by 2 on each side. And so x is equal to 3.5 or 3.5. Now that subtraction may look funny. Most people are used to the straightforward method. So 2x plus 5 is equal to 12. We can say that subtract 5 on either side. So we have 2x plus 5 minus 5, and then it's equal to 12 minus 5. And we remain with 2x is equal to 7. And to get x, we divide both sides by 2. X is equal to 3.5 or 3.5. With time, people get used to solving equations and use the statement, take it to the other side. When that happens, the sign changes as well. And so in 2x plus 5 equals 12, we take 5 to the other side. It becomes minus 5. And so you have 2x is equal to 12 minus 5, giving us 2x is equal to 7, and x is equal to 3.5 or 3.5. Whichever method suits you, it is still correct. How about 2x minus 5 equals 12? Now in this case, to get rid of minus 5, we have to add. So 2x minus 5, we add plus 5. And is equal to 12, we also add 5. So we have minus 5 plus 5 is 0. So that side remains 2x. On the other side, 12 plus 5 is 17. So 2x is equal to 17 and x is equal to 8.5 or 8.5. For the quicker method, 2x minus 5 equals 12. Take minus 5 to the other side, it becomes plus 5. And so we have 2x is equal to 12 plus 5. 2x is 17, dividing both sides by 2. X is equal to 8.5. If you have 5x minus 5 is equal to 3x plus 3, you keep the unknowns on one side and the constants on the other side. So take 3x to the other side. It becomes minus 3x. And so we have 5x minus 3x minus 5 is equal to 3. Now take minus 5 to the other side. It becomes plus 5. So we have 5x minus 3x is equal to 3 plus 5. So that gives us 2x is equal to 8. To get x, we divide both sides by 2. X is equal to 4. It is that simple. But the problem comes with complicated fractions. For example, a half x plus 2 over 4x is equal to 3 over 2. The best and the fastest way is to find the LCM of the denominators, and then we multiply each term with that LCM. That way, you will remain with the denominators alone. And so the LCM of 2, 4, and 2 is 4. So we multiply each item by 4. If we cancel that, by 2, 1, by 2, 2. By 4, 1, by 4, 1. And by 2, 1, by 2, 2. And so we have 2x plus x is equal to 6. 3x is 6, and therefore x is equal to 2. And now we move to simultaneous linear equations. Now in the examples that we were solving, there was only one unknown, either x or y. Consider an equation x plus y is equal to 7. Is it possible to find the values of x and y? No. We can only do that if we are given another equation in x and y. For example, x minus y is equal to 3. We call the two equations simultaneous linear equations, and that means the values of x and y will satisfy both equations simultaneously or at the same time. There are 4 methods of solving simultaneous linear equations, but we will look at 2 for now: elimination and substitution. Let's take an example. 5x plus y is equal to 9, equation 1, and 3x plus y is equal to 1, we call it equation 2. Now elimination means we first eliminate one of the variables, either x or y. How? By either subtracting or adding the two equations, whichever is necessary. Consider these equations. Suppose we want to eliminate y. Then we shall subtract equation 1 minus equation 2. If we do that, 9 minus 1 is 8. The equal sign, y minus y is 0. And then 5x minus 3x gives us 2x. And so we remain with 2x is equal to 8, and x is therefore equal to 4. Now we have the value of x. To get the value of y, we substitute that value of x in any of the equations. If we choose the first equation, then we shall have 5 times 4 plus y is equal to 9. Notice that 4 has taken the place of x. So 5 times 4 is 20, plus y should give us 9. Therefore, y is equal to minus 11. Now let's consider the first equations. X plus y equals 7 and x minus y equals 3. The easiest variable to eliminate is x because we will subtract right away. We end up with 7 minus 3 will give us 4. Y minus y is equal to y plus y, and that is equal to 2y. X minus x is 0. So we have 2y is equal to 4. Y is equal to 2. And then we substitute y into any of the equations. If we choose the first one, x plus 2 is equal to 7, and therefore x is equal to 5. Suppose we want to eliminate y instead. If we want to have 0y, then we cannot subtract. Instead, we add the two equations. So we shall have 7 plus 3 is 10. Y plus minus y is 0. X plus x is 2x. And so 2x is equal to 10 and x is 5. The same answer we got. With this, now you can find the value of y by substitution. And so it is not always that the two equations will be subtracted. You need to check the signs, plus or minus, and see whether to add or subtract. Sometimes, the coefficients of the variables may not subtract each other out. For example, 2x plus 3y is equal to 12, x plus y is equal to 5. If you subtract the two equations, you will end up with x plus 2y is equal to 7. Nothing has been eliminated. And if you add them, you get 3x plus 4y is equal to 17. Again, nothing has been eliminated. The reason is that the variables have different coefficients in each equation. Can we still eliminate? Yes, we can. This is how we do it. We decide which variable we want to eliminate. Let's say we choose x. And now we need to make x have the same coefficient in both equations so that they can subtract. Let's make the coefficient of x in both equations 2. So we multiply the first equation by 1 and the second one by 2. And we shall have 2x plus 3y is equal to 12. And 2x plus 2y is equal to 10. For as long as you multiply the whole equation, it does not change its meaning. And now we can subtract. We get y is equal to 2. It's so simple. Now we can find x. Substitute y in any equation, even the one you multiplied. Let's substitute here. X plus 2 is equal to 5, and so x is equal to 3. Now substitution method. In this method, we simply express one of the equations in terms of one variable and substitute into the other. Consider x plus y equals 7, x minus y equals 3. We choose any equation and express x in terms of y or y in terms of x. It doesn't matter. Let's take the first one. X plus y equals 7. And so x is equal to 7 minus y. We substitute 7 minus y for x in the second equation. So where there is x, we put 7 minus y. And so we shall have 7 minus y is equal to 3. Minus 2y is equal to minus 4. And y is equal to 2. Now find x. Substitute 2 for y anywhere. So x minus y is equal to 3. Substituting, we shall have x minus 2 is equal to 3. And therefore x is equal to 5. How about 2x plus 3y is equal to 12, and x plus y is equal to 5? We rearrange the second equation. It is the easier one. And let's use y this time. So y is equal to 5 minus x. Now we substitute y in the first equation. 2x plus 3 times 5 minus x is equal to 12. 2x plus 3 times 5 is 15. 3 times minus x is minus 3x is equal to 12. Minus x is equal to minus 3. Divide either side by -1 and we get x is equal to 3. What is y? We substitute 3 for x in any equation. We take the second one. 3 plus y is equal to 5, and therefore y is equal to 2. Let's take an example. 2 pencils and a book cost 50 shillings. 3 pencils and a book cost 40 shillings. Find the cost of each item. So let the price of a pen be represented by P and that of a book be represented by B. So 2P plus 3B is equal to 50 and 3P plus B is equal to 40. Let's start with substitution. We rearrange the second equation. 3P plus B equals 40. When we rearrange, we get 3B is equal to 40 minus P. We substitute this into equation 1. 2P plus 3 times 40 minus 3P is equal to 50. 2P plus 3 times 40 is 120. 3 times minus 3P is minus 9P. That is equal to 50. 2P minus 9P is equal to minus 7P. We take 120 to the other side, it becomes minus 120. So 50 minus 120 is minus 70. If we divide both sides by minus 7, P is equal to 10. Now substituting the value of P, we get 3 times 10 plus B is equal to 40. 30 plus B is 40 and B is equal to 10. How about elimination? We have 2P plus 3B is equal to 50 and 3P plus B is equal to 40. Let's eliminate P. We need to make them have the same coefficient. So we multiply equation 1 by 3 and equation 2 by 2. We will get 6P plus 9B is equal to 150 and 6P plus 2B is equal to 80. 150 minus 80 is 70. 9B minus 2B is 7B. 6P minus 6P is 0. So 7B is equal to 70 and B is equal to 10. Substituting the value of B in an equation, 3P plus 10 is equal to 40. 3P is equal to 30 and P is equal to 10.
If you've had a bad experience with math, you tend to sort of slough it off, and that's a serious mistake, I think. I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place.